Hello, I Anand Jain from Hanumangarh, Rajasthan welcomes you to your favorite Shridevi classes YouTube channel where we inculcate interest and confidence in science and engineering subject. Today in our class 12 senior secondary physics playlist, in our chapter of electromagnetism, we'll study Biot Savart Law and will describe law and then find out magnetic field contribution of a straight current carrying length. We will derive the relation of magnetic field flux density from a straight conductor at certain perpendicular distance. And this question is usually asked in our board examination too. And then finally, we will explain magnetic field of an infinite length current at middle and end positions. Let's start. In next 20 minutes, we will first discuss Biot Savart law and describe its expression. Then we will derive magnetic field of a straight current carrying conductor at certain perpendicular distance, and this will improve both your subject understanding and scoring ability in coming exam. But let us start with Oersted discovery. In year 1819, Oersted found that a current carrying conductor or a moving charge can produce magnetic field around it, and for a straight conductor, this magnetic field is in the form of concentric circle, and the direction of this magnetic field is obtained by Maxwell. And Maxwell gave two rules. One is right hand thumb rule, which says that if conductor is gripped in right hand with thumb pointing the direction of current, then the curl of finger indicate the direction of magnetic field in concentric circle around this straight conductor. Whereas in right hand corkscrew rule, we have to rotate a screw in a cork such that screw should progress in the direction of current. Then the direction of rotation of screw indicate the direction of magnetic field. Now both right hand thumb rule and right hand corkscrew rule are similar in application, but right hand thumb rule is little bit more convenient. Oersted has discovered that a current carrying length can produce magnetic field around it, and the direction of that magnetic field is obtained by Maxwell right hand rule. But the magnitude relation of magnetic field with current and geometric orientation was first given by Biot Savart as Biot Savart law, and Biot and Savart, two scientists, assumed that a small elemental length carrying current become a current element length, and that current element is source of magnetic field at any observation position, and at point P, which is at r distance from this current element, and the position vector of this observation point from current element makes an angle theta with current elemental length. Biot and Savart observed that elemental magnetic field intensity contribution from a current element length is directly proportional to strength of current element, that is product of current passing through conductor and elemental length whose contribution we are observing at observation point. This magnetic field is inverse of the distance of observation position from current element, so it is 1 over r square relation of magnetic field strength, and magnetic field also depends upon orientation angle theta of position vector with current element, and dependency is magnetic field is directly proportional to sine of that angle theta, and this proportional relation when combined and converted into equality, we have to use a constant 1 upon 4 pi, and since magnetic field is a vector quantity, so its direction is denoted by this unit vector n cap. Now this relation can be converted into vector notation as cross product of current element vector and position vector of observation point from current element r cap, and magnitude of cross product is first vector current element, second vector got unity magnitude, and the sign of the angle between first vector and second vector, that is sine of theta, and this become vector notation of magnetic field intensity. And if someone is interested in elemental magnetic flux density contribution from current element, in place of H we can find out relation of B, as B is directly proportional to H and proportionality constant is permeability of medium. If this medium is air, then permeability of air or vacuum is mu naught, and this relation of elemental magnetic flux contribution from a current elemental length at a r distance position is given by this relation. Elemental magnetic field flux density contribution is equal to mu 0 upon 4 pi cross product of current element length and unit position vector, which connect source current element to test position where we have to find out magnetic field contribution, divided by square of the distance between current element and test position. If current is in ampere, distances are in meter, then magnetic flux density is in Tesla unit. And the direction of elemental magnetic flux density contribution is obtained by vector product law, which says that resultant vector product of two vectors is perpendicular or normal to the plane which contain these two current element vector and position vector. And this screen got current element vector and position vector, and magnetic flux density is normal to this screen either upward or downward, and the direction is given by right hand corkscrew rule, which says that in a cork, when screw is rotated from first vector to second vector through smaller angle, then the progress of screw in cork represent the direction of magnetic field, and it is cross or inward as indicated in this drawing. This relation in red frame and yellow highlight is vector format of Biot Savart law, and it says that elemental magnetic contribution at point P by a current elemental length I delta L is directly proportional to cross product of current element and position vector, and it is inverse of the square of the distance between current element and position 1 over r square, and proportionality constant is mu 0 upon 4 pi, and this direction is given by corkscrew rule. And when we have rotated a screw in a cork from first vector current element to position vector through smaller angle in clockwise direction, the screw goes inside the cork, so the magnetic field is directed in vertical downward direction. On this screen, the direction of elemental magnetic contribution by current element can also be obtained by right hand thumb rule of Maxwell. And thumb rule is convenient in application also. The thumb of right hand is directed in the direction of current in current element, and this curl of finger represent circular shape of magnetic force lines around this conductor, and these magnetic force lines as tip of the fingers indicate that magnetic field is inward at this P position. The vector notation of Biot Savart law is written as elemental magnetic contribution by current element length is given as mu 0 upon 4 pi multiplied by I delta L sin theta upon r square, and the direction of current element vector is normal to the plane of current element and position vector as denoted by n cap direction. Now this relation clearly indicates that magnetic contribution of a elemental length or straight conductor depends upon the position of test point with respect to conductor, and if test position is along the axis of elemental length or a straight conductor, then in that case angle theta between current element and position vector becomes 0, and sin theta for theta equal to 0 also becomes 0. So elemental magnetic contribution becomes 0. So a straight current element or a long straight conductor won't produce any magnetic field contribution along its own axis, whereas for a perpendicular positions, when theta is 90, sin theta become maximum 1, and a current element or a straight conductor will produce maximum magnetic field contribution for theta equal to 90 degree, and the perpendicular separation of observation point is also minimum from current element length. So this inverse square relation also support increment of elemental magnetic contribution. Now this Biot Savart relation gives magnetic field contribution of element length for a long current carrying length. To obtain total magnetic contribution at any observation point, we have to make integration techniques, and this differential format equation is integrated to obtain the total magnetic field contribution of a current length. We are given a straight conductor AB carrying I current, and we have to find out magnetic field of this straight current carrying conductor at observation position P, which got minimum perpendicular distance capital R from this conductor. Now to apply Biot Savart law, we consider a elemental current length I delta L over this AB length of current carrying conductor, and its elemental magnetic contribution at observation position P is given by this relation mu 0 upon 4 pi I delta L sin theta. Here theta is angle between current element length and position vector of observation position P from current element, this theta, and divided by r square, where r is distance of observation point from current element, and it is directed normal to the plane of current element and position vector or this screen plane. And if we apply Maxwell right hand rule or Maxwell corkscrew rule, then we'll get the direction of elemental magnetic contribution by current element I delta L at this observation position P inward as shown by this cross here. Now other current element length on AB state conductor also contribute magnetic field here with different magnitude, but all magnetic contribution at observation position P by this entire AB length are in the same direction, that is perpendicular to this screen plane and inward, shown by cross here. So the vector summation of elemental magnetic contribution become simple algebraic summation for this entire AB length, and that can be obtained by simple integration of this result for integration limit a to b of this straight current carrying conductor. So elemental magnetic field contribution delta B by elemental current length I delta L is given by this relation as per Biot Savart, and for entire AB length which is carrying I current, the total magnetic field at observation position P can be obtained by summation of all elemental contribution, and since all elemental contribution are in the same direction, so the vector summation of magnetic flux density become a simple algebraic summation, and elemental magnetic contribution when integrated for this AB length limits will give us total magnetic field contribution by current carrying AB length at observation position P. But when we perform integration of this elemental magnetic field contribution, then we got three variable here for different elemental length section. Length itself is a variable, and elemental vector with position vector R makes an angle theta, and that theta also change when elemental length on AB wire change, and the distance of observation position P from current elemental length, this R is also variable for different elemental length sections. So this three variable relation is very difficult to integrate, but we can convert these three L, theta and R variable into a single variable theta using this given constant, that is minimum perpendicular distance of observation point P from AB current carrying length, and in this triangle with theta angle, this is perpendicular, this is base, and the ratio of perpendicular to base is tan theta, or we can say the perpendicular intersection point and current element length distance L is given as R cot theta, and when we differentiate it, the length differentiation is elemental length delta L, R is a constant, and cot theta got a differentiation minus cosec square theta d theta, and we can substitute length variable in terms of constant and theta. Similarly, in the same triangle, sin theta is perpendicular upon hypotenuse and small r is r cosec theta, and we can substitute small r in terms of capital R and variable theta. So elemental magnetic field contribution now become mu 0 upon 4 pi. I is the same, and in place of delta L we have written minus r cosec square theta d theta. Sin theta is same, and for small r square we have written square of r cosec theta, that is r square cosec square theta, and in simplification 1 r from numerator get cancelled by denominator r square, and cosec square theta also get cancelled out, and our relation become mu 0 I upon 4 pi r minus sin theta d theta, and now there is only one theta variable, the remaining I and capital R are constant. So we can perform this integration from B to A limits, and the single variable is theta, and theta is angle of current element and position vector as shown here, and for one limit it is theta 1, and for second extreme limit of conductor at position A it is theta 2 as shown in this diagram. So for theta 1 theta 2 limits we can make this integration to find out total magnetic field produced by AB current length at observation position P. When delta L and observation position distance small r are converted in terms of capital R and this variable theta, the elemental magnetic field contribution from small current element length I delta L at position P gets simplified as mu 0 I upon 4 pi r minus sin theta d theta, and for total magnetic field calculation of AB length carrying I current, we have to make integration from theta 1 limit to theta 2, and this become our relation for total magnetic field contribution of AB length at position P. Now mu 0 I 4 pi r all are constant, they are come out of integration, and sin theta integration is minus cos theta, with this minus it become plus cos theta, and these limits are taken at outside of this big bracket, and in place of this variable theta once the acute angle theta is placed, and then with sign change obtuse angle limit theta 1 is taken. Now to decide from which angle to which angle we have to make integration, we have to consider that first the smaller less than 90 angle should come, and then more than 90 degree angle theta 1 should come with negative sign, so that when this become obtuse angle more than 90, its cosine become negative, and with negative sign that become positive. Now in place of this obtuse angle, we can represent this in terms of inner angle theta 1 dash, which is an acute angle, and we know cos theta 1 is minus cos theta 1 dash. So in place of cos theta 1, when we place cos theta 1 dash, it become with this negative sign, this negative become positive. So our relation become mu 0 I upon 4 pi r cos theta 2 plus cos theta 1 dash. Now it is quite easy to remember 2, as both theta 2 and theta 1 dash become inner angles, and there is a summation sign, so any one term can come before the other one. So this red frame relation represent the total magnetic field contribution of AB length from I current at perpendicular r distance as mu 0 I upon 4 pi r, and this observation position from two extreme limit produce two acute angle theta 1 dash and theta 2, and cosine of both are added together and multiplied with mu 0 I upon 4 pi r to give total magnetic contribution of AB length at position P. So total magnetic field at position P by this AB length carrying I current and having r perpendicular distance is given as mu 0 I upon 4 pi r cos theta 2 plus cos theta 1 dash, where theta 1 dash and theta 2 are inner acute angle of current element length and position vector at two extreme limits of this current carrying state conductor. Now in this BOP triangle, the summation of theta 1 dash and alpha 1 is 90 degree. So in place of cos theta 1 dash, we can write sin alpha 1, and similarly in triangle AOP, the summation of theta 2 and alpha 2 is 90 degree. So in place of cos theta 2, we can write sin alpha 2, and in place of theta 2 and theta 1 dash, we can get the same magnetic field contribution of this AB length at r perpendicular distance in another format, mu 0 I upon 4 pi r sin alpha 2 plus sin alpha 1, where alpha 1 and alpha 2 are angle at observation position P by two extreme distance vector with perpendicular on AB conductor, this alpha 1 and alpha 2, and our result is sine of alpha 2 plus sine of alpha 1. One could remember in our original Biot Savart formula, theta is angle between current element and position vector here, and in Biot Savart formula, elemental magnetic contribution got that theta in form of sine theta, and when integration is performed to find out total magnetic field, that sine theta become cos theta, and we got result in terms of cos theta 2 plus cos theta 1 dash, and if in place of theta we want to use result in terms of alpha angles, then our result will be in sine format, sine alpha 2 plus sine alpha 1, and the multiplier in both cases mu 0 I upon 4 pi r. So we can summarize that magnetic field contribution by a straight current carrying length carrying I current and perpendicular distance r is given as mu 0 I upon 4 pi r multiplied by cos theta 2 plus cos theta 1 dash, where theta 2 and theta 1 dash are inner acute angle of position vector and current element at two extreme positions, and the same result can be written as total magnetic contribution is mu 0 I upon 4 pi r sin alpha 2 plus sin alpha 1, where alpha 2 and alpha 1 are angle with perpendicular bisector and position vector with two extreme conditions alpha 1 and alpha 2 as shown here in this diagram. Now if this conductor length is not finite but infinite length, then in that case, if our observation position is midway, for infinite length, these two lines, position vector and current element, become parallel to each other, and theta 2 and theta 1 dash become both 0, and both alpha 1 and alpha 2 become 90 degree, and in that case cos 0 plus cos 0 is 1 and 1 summation 2, and similarly sin alpha 2 plus sin alpha 1 with alpha 1 and alpha 2 both 90 degree also become summation 1 plus 1 2, and this 2 with 4 pi r when simplified give us result mu 0 I upon 2 pi r at this position in Tesla. And for the same infinite length, if observation position is at one extreme end, then in that case one theta become 0, another theta become 90 degree, and cos 0 become 1 and cos 90 become 0. So this summation is only 1, and our result will become mu 0 I upon 4 pi r, half of central value at extreme positions. In practical conditions, in comparison to this perpendicular length, if conductor AB length is 100 times or even more, we can treat conductor as infinite length conductor for such near about test positions. One typical example is our overhead transmission line conductors can be treated as infinite conductors if test positions are 1 or 2 meters away from these conductors. So for infinite current carrying length, when observation position is at middle position, then magnetic field become mu 0 I upon 2 pi r, and when observation position is at one end of infinite length current carrying conductor, then magnetic field at this endpoint position become mu 0 I upon 4 pi r Tesla, which is just half of midpoint magnetic flux density, and these relations clearly indicate that magnetic contribution of current carrying length is directly proportional to current. If I double current in a conductor, magnetic field flux density or magnetic induction also get doubled at observation position. This magnetic field contribution is inverse of the distance, both at mid position mu 0 I upon 2 pi r and at extreme end position mu 0 I upon 4 pi r. It means when we double perpendicular distance of observation point from straight conductor, the magnetic field will become half. Note that elemental current length has produced elemental magnetic contribution as inverse of the distance square. It obeys inverse square relationship, but for integrated result of total magnetic contribution, it becomes just inverse of perpendicular distance. We hope this informative learning video has explained Biot Savart Law in complete detail. Now you can comfortably derive relation of magnetic field contribution by a straight current carrying length by mathematical manipulation and integration, and you also understand how we can find out magnetic field contribution of infinite length at middle position and end positions. Our other learning video of the same playlist are equally useful for your exam preparation. You can use them in your studies and can share them with your friends. And if you need our online doubt clearing classes or dedicated exam centric notes, do join our membership by clicking join button just beneath. Thank you very much.